All right.
Okay. Well, welcome to the November 26th, 2024 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week, um, my wife has had me working, getting the house ready for Thanksgiving, so that's taken some of my time. But I have been working on cleaning up and trying to better develop some information to help. I've started writing a series of articles, and I want to be able to help people coming to using Whisper K9Q radio, help them understand and um, set up radios. So I've been working on that, and we'll see where we get as we go along. So next on the list is Nathaniel, W2NAF. I see you got a paper out.
I got a paper out. Which one?
Well, at least an abstract.
I
The
got, well,
AGU.
yes. Yes, there are AGU abstracts out. So, okay, there's a lot that's been going on. So, first of all, last week, Gareth and Perry and I went out to Colorado to Boulder, and we spent about 3 or 4 days at the National Science Foundation Cedar Science Steering Committee meeting. And so this is the CEDAR is, of course, the coupling of energetics and dynamics of atmospheric regions effort that runs the annual workshop that we go to every June. And that's also pretty much the program that the Personal Space Weather Station is funded under. So it's not a sort of part of it's funded under that program, but if it's not funded under that one exactly, it's very closely related. So I think we had a good meeting there. I think the citizen science is generally well regarded. So that's good. We're moving things along there. When I got back on Thursday, we had a big snowstorm here in Scranton, and I was still in Colorado at the time. It was lots of very heavy snow. It took down all sorts of trees. We lost power at our house for 3 days, and fortunately, we had a whole house generator going. And so we really made good use of that this year. So that kept that going. I did unfortunately lose my main ham radio antenna. So that was the ZS6BKW. So once the snow melts a little bit out here and I get a little time, maybe over Thanksgiving break, hopefully we'll be able to repair that and get that back up without too much trouble. I think everything else is pretty much good. Jonathan will be able to give you a report as to what the VLF receiver heard in the area, because when the power went out, all these people put on all sorts of different types of generators. Some generate more noise than others. And Jonathan can give you a very good assessment of that. Over the next couple weeks, of course, we've got Thanksgiving coming up, and at the University of Scranton, we have wrapping up classes, so final exams. So we're working on that. But then the week of December 8th, we have quite a number of people going to the AGU conference. Um, and so that's coming up. We're sending 8 of my students from the university, plus Mary Lou West and Steve Serwin from HamSCI, couple other faculty members as well. And those are just the people from the University of Scranton. I'm going, and then also from NGIT, Gareth Perry is going, and Kuldeep's going to be giving a poster on his solar eclipse QSO party effort. So that's going on. For me personally, I'm going to be giving 2 oral presentations on the solar eclipse QSO party. The first one is a 10-minute presentation on Monday afternoon. And that one is in a union session where I'll be talking about how we did kind of all this community building and more the organization of our eclipse efforts. And then during that talk, I'm going to try to advertise all of the other different talks that happen throughout the week. So I'll probably have a link that goes to the HamSCI newsletter and a big QR code where people can get that, and that will have a list of all the HamSCI presentations at AGU. And then on Friday afternoon, I'm giving a talk in a session that's organized, convened by both the NSF and NASA program officers for the eclipse. And so I'll be highlighting different high-level results from the eclipse in that session. On Tuesday morning, I have a NASA press conference about the eclipse. So I have to be ready to go with all sorts of eclipse news and science results from that. So to help me get ready for that, we've been having Monday mornings. We now have a group of people, including Gareth Perry, Kuldeep, Rachel Bodeker, Jamal's been showing up, David McGaw, and who, and a few other people. They've been showing up, and so Joe Hubo was there this morning. So we went over the different talks that I'm giving and that Kuldeep is giving, and so we're getting that all pulled together. So by next Monday night, I should be able to have a draft of all the presentations that I can show you. I think we're gonna go from there. I think that's all I've been doing. I think
Just a few things.
Oh yeah, I am running some ray tracing on the side too to try to simulate LSTIDs. And I know Michael Howen, I'm excited to hear from Michael Howen and Rob Robinette in the antenna group, because I know they are looking to test some additional antennas, and I do want to work as a test site, so I can get them information about we can work on getting antennas to me to deploy those here. So okay, back to net.
Okay, well, thanks for that report. Next on the list is Dave KD0 EAG. Go ahead, Dave.
I should have been thinking. I've been doing various things. I've been doing a lot with ordering boards and parts and all the various complexities of that, and trying to get some stuff in place uh, in case there are changes in the international trade picture, where and I've also been doing some board testing. Also been playing with some uh, a little bit of coding on the KA9Q web related stuff, and a certain amount of experimentation with 10 gig Ethernet, and trying to find out what kind of data transfers can be put across that over the USB IP protocol, in a sense to possibly remote devices out away from noise sources. But it's not simple, or it's not straightforward or economical. So, but I'm playing with that just as a learning thing. Hopefully things will improve over the next uh, over in the near future. Otherwise, that's it for me.
Yes, and I will mention that we at TAPR are very thankful for Dave stepping in and producing some boards from somebody that couldn't do it anymore. So want to try to keep our star going. Okay, next on the list is Bruce, WB4MJG. Welcome, Bruce.
Well, thank you, and good evening to everyone. Uh, I've not been very productive at all. I'm in the process of workshop and discovering a lot of things I forgot I had that got stuck back under the bench. Like, yeah, I remember starting that project,
Yes.
what, 3 years ago. Things are going well. Been playing with some of the little tiny ESP32 boards with Wi-Fi and Bluetooth, and SPI and I2C and probably several protocols. So it's a learning curve. So it's little
Very
tiny
good.
things like those.
Well, we're actually, there's several projects that are incorporating some of those. So very
Oh,
efficient ways to get communications from them to the rest of the network.
yeah, it's amazing little devices, and my stars, you can buy them for $5 in a dozen places. You know,
Yes.
a lot of computing power.
Yes.
When I compare them to my punch card days.
Oh, yes.
But anyway, I digress. But
I have
anyway,
some of those punch card days myself. So
yeah, that was a long time ago.
yeah.
Anyway, back to Ned.
Yes. Next on the list is Clint, KA7OEI. Go ahead, Clint.
I not a lot to report, but I did notice Rob sent me a note that a field probe is on the way. We intend to install that, but we haven't decided to receive hardware to use. We had to have a spare 888. We could install that at the Utah SDR side. At least it would be in a relatively quiet location, and we do have an extra cable that runs to a tower that is 180 feet or so from the power line ish. So that should at least be something to try it out there and compare it with the Omni and stuff that's out there. Don't have too much else besides that. Just back to you then.
Okay. Next on the list is Dave H, W6OQ. Go ahead.
Evening, everyone. As usual, I'm just sort of hanging here and seeing what I can get into.
Okay. Thank you. And next on the list is Dave Julian, WB9YIG.
Good evening, folks. Not much going on. Just got done doing a couple satellite contacts, so was glad to see my station is still operational. So that's about all for here. Back to the net.
Okay. Next on the list is Dave McGaw. Go ahead, David.
Good evening, everyone. Continuing to work on local projects and antenna testing and the like, and trying to get our AM Doppler system to behave. And had one interesting thing on the ham radio side where our Kenwood repeater went down, and we're kind of looking to clear out equipment that's been abandoned up on the roof of the building where these things are, and discovered that Network Services had abandoned a UHF repeater, a Bridgecom, that I was able to commandeer and reprogram and put us back on the air. But you never know when you can SCUA something useful. I don't know if people know that term, but that comes from us Antarctic explorers. SCUAs are the industrial strength seagulls that will, if you're walking across the yard with any kind of food, they will snap it right out of your hand. And so in the recycling center, there's the plastic, there's the glass or metal and such, and then there's the SCUA bin where you put anything you think might be useful to somebody else. Back to Ned.
Very good. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Trying to keep out of trouble. Spent a lot of time in the CQ Worldwide DX contest this weekend, which I found rather interesting because it was a CW contest and 10, 15, 20 meters were wide open. And there are a lot of signals going directly over the pole. And especially on Sunday morning, there were some rather interesting either echoes or multi-path signals, especially coming from Central Asia. Maybe a little bit of far northeastern Europe too. But the over the pole path had some interesting anomalies on their signals. But on the HamSCI side of things, I just uploaded the data, all the raw data, calculations and whatnot for the 2023 running of the Gladstone Signal Spotting Challenge. Put those up in Zenodo. It's the first time I upload anything into Zenodo. And about 5 minutes later, Christina Collins says, looks good. So I think that's what I'll be working on the rest of the week, is continuing on for the GSSC and get the SDQP data up there. So back to net.
Very good. Thanks for doing all that. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening. Not a whole lot to report here. I was in the vanguard of a bug of some sort that's going around down here, and I've been pretty much flat on my back for the last 10 days or so. So not a whole lot to report. I have been looking a little bit. It's finally getting cool here, so I could get some idea of the housing that I put over my magnetometer experiment to try to keep its temperature a little bit more stable. It's still dropping fairly fast. I haven't compared it with last year yet, but it's dropping faster than I was hoping it would. So we'll see how that comes out. Back to net, K4BSE.
Okay. Next on the list is Jonathan, KC3EY. So digging out of snow, Jonathan? Is he there? Johnson, your mic muted. I don't know if he's there.
He's usually here. We come back to him.
We can come back to him. Next on the list is Larry, N6NC. Go ahead, Larry. He's mic muted. Okay, no response from Larry. Next is Lawrence. And I would not pronounce his last name correctly. I'm sorry. Lawrence,
Good
are you
evening,
there?
everyone. Yeah, I'm here. Can you hear me?
Yes, please pronounce
Hello?
your last name.
Yes. It's Habahabi.
Okay,
Yeah,
very
it's-
good.
yeah, yeah. Thanks, Dave. Thank you. Well, good evening, everyone. Nothing to report here. I'm still learning the ropes, so I'm doing a lot of reading regarding basically building circuits and the mathematics behind antennas and things like that. So it's really an interesting learning experience for me, and I'm very glad to participate in this sort of forum. Thank you all.
Yes, and if you find it interesting, please come back.
Absolutely. Thank you.
Yeah. And I see Larry's there now. So Larry, N6NC, go ahead.
Good evening, everyone. I'm continuing my obsessive observation of the Russian KCW beacon on Kamchatka in my continuing studies of 40-meter propagation. Rob, AI6VN up in the Bay Area has very kindly added that channel to his digital recording setup. So we have a record of that. He's also, as a backup to my recordings, added the Nagoya University Hokkaido Super Darn HF radar that I've been recording twice a month for almost 4 years now, I think, 3 or 4 years. Also, I think I sent it to the wrong person, but I'm seeking permission or help to get Rob's feed of the K-beacon frequency somehow fed into the PSWS network that shows the Doppler spread on this as well as signal amplitude, because I can monitor the signal amplitude regularly on a Grafana setup that Gwyn G3 ZIL has prepared for me. And then if we see any unusual propagation events, if I could go to that PSWS network, I could immediately see the Doppler shift, which then allows me to look at potential time of arrival paths. You know, think of red shift and blue shift, if it's a longer path or shorter path and so on. I've been trying to do that with my little recording oscilloscope here, but it's not good enough, and that would really help out in our 40-meter propagation studies. Somebody mentioned before over the pole paths on various bands. I can tell you that listening to this 40-meter signal, it's a Russian beacon, and at the same time, often in the evening here on the West Coast, I can hear the I think it's the U beacon that's in Uzbekistan on the same frequency. And so I've asked Carl K9LA, and we're trying to figure out what the path is for that on 40 meters. So that's kind of an interesting thing with these good sunspot numbers. And that's about all I have.
Well, that's good. Thank you for that report. Let's see. Next on the list is Michael Howen, AC0G. Go ahead, Michael.
Thanks, Dave, and good evening, everyone. I haven't accomplished a lot ham radio wise, I guess. I've communicated with Glenn regarding getting a third test antenna here. And I know he's planning on putting it in other places as well to stake out some of the bugs, and at the same time we can make some comparisons with the DX Engineering antenna and with the LZ1AQ type antenna. Dave McGaw, I don't know what's going on with the local site for the AM Doppler study. It's on my network. I don't know why it's not reporting to the Dartmouth Central site. The North Dakota one, I'll have to, as I mentioned, get my sister to see if she can kick the machine. In regard to what Nathaniel mentioned a little bit earlier about the AGU, I will note that I cite a SynthPi receiver here in central Missouri and another one up in North Dakota at my mom's house in Fargo. And a poster presentation for the AGU is in the works by I'm not sure who all's on it. The Professor Fabio, let me see,
Fabiano
Fabiano
Rodriguez
Rodriguez and a bunch of others, Jose
and her.
Maria Gomez Socola,
Mhm.
and you, Nathaniel, and Phil Erickson, and a variety of others. And they were kind enough to list me as a citizen scientist on it. So that's
Perfect.
very nice. And that's it for me. Thanks. Back to
Okay. Next on the list is Phil, K9Q. Go ahead, Phil.
Hey guys, nothing really to report from here, but I am interested in any reports on using KNIQ radio with the RS888 at the full sampling rate to get 6 meters. I know there's been discussion about anti-aliasing filters inside the RS888 and modifications of Paul's WB6CXC's shelving filter. So I'm interested in any reports of that because I keep hearing that 6 meters is really doing well these days. And that's it from here.
Okay. And then next on the list, we have Scott Newell, N5TNL. Go ahead, Scott. You have a mic.
Yeah, I do tonight. My homework assignment from last week was to try the narrowband WWV sideband recording with K9Q radio, but I didn't consider that 40 hertz band width and 200 hertz minimum sample rate, so that didn't work out so well. But considering we have the wideband WWV recordings already, I'm now playing around with the whole shift, filter, and decimate. So that's about it for me, and back to Nat.
Okay. And it's nice to hear your voice. Next on the list, we have Tom in 5EG. Go ahead, Tom.
Okay, good evening, Dave. Not too much here. I've updated to the latest Xilinx tools, but I haven't tried them to see if I can recompile the test FPGA I was looking at. My FPGA book is somewhere in one of 21 boxes in the garage. And so time to go exploring the garage. Back to the group.
Very good. And I believe I've been through everybody. Is anybody? Oh, Dave New. I skipped over you. I'm sorry. Go
That's all
ahead.
right. Yeah, I I guess about the only news that I have is I just took my Geocron Atlas 1 and I've got it shipping back to the mother load because they now have an upgrade program for people with Atlas 1s to get an Atlas 2. And you get a $150 off coupon. And on top of that, the Atlas 2 is on Black Friday sale right now, so knocking $75 off the Atlas 2. So this is as good a time as any to do it. And I'm a very happy user of the digital Geochron. I have a 4K display up on the wall over the radio here in the Ham Shack, and I run the Ham Premium bundle on it. Oh yeah, by the way, the Black Friday sale also includes 1 free year of a premium bundle. So if you've been putting off getting a digital Geochron, maybe this is a good time to think about it. But I certainly have really enjoyed mine. It shows all the packet spots and stuff on it, and you know, so it's at a simple glance I can see kind of what the HF propagation is like. So, but that's it. Back to Net.
That's interesting. Thank you. Okay. Any other people that I seem to have missed? As you know, the participant list jumps around as you change the status of your buttons. And so that's can cause me to jump over somebody.
Still haven't heard from Jonathan.
Oh, Jonathan. Jonathan, are you there? Maybe Nathaniel can send him a message.
Sure, I'll send him a text message.
Got to get Rob Robinette too.
Yeah. Oh, that's right. Well, we usually let Rob talk last.
Because I can't, and I try to shut up for as much as possible. I know I can take things over, but if Jonathan is there, he should go first.
Okay. Well, I don't hear from Jonathan.
Okay. Well, I'd like to hear from him because I'm very interested in the ELF stuff.
Yes.
So that's why. But in any case, let me go through what I've been working on for the last week. We had a WhisperNet outage. Well, WhisperNet didn't go down, but Whisper Daemon's communications with WhisperNet went down. And it took several days for us to figure out that it was a password problem that somehow the scrapers were out like. So we had an outage for a few days, but apparently all of the spots during the outage from, I think it was Tuesday afternoon through Friday, I think they've all been restored to the Whisper Daemon scrape. So I don't think we permanently lost any information. But it pointed out a vulnerability, which we hope we have frailty that we've hopefully addressed. Yes? Question? No? Okay.
No.
another topic, 32-bit float, is the AGC project for Whisper Demon Grape. Scott, thank you so much. I can't tell you how grateful I am for you having produced the version of the recorder that records the 32-bit float samples. I've manually established that I can take those samples and create the decode whisper samples, and I can also forward the 32-bit float recordings to the PSWS server. So over the next week or so, I expect that most of the 20 plus Whisper Demon Grape sites will start contributing 32-bit float recordings. And I think that will address, there's some corruption inevitably with the current architecture introduces amplitude errors in the recordings, and those should go away when we get to 32-bit floats. We may get a few more spots. I don't think that's not the point of 32-bit floats. It's really the AGC thing. I have another subject, antennas. The Glenn N6GN is entered to the stage where he's ready to do alpha testing of his design. And I've put him in contact with you. Michael, I think you had already responded to his, Glenn had posted a request for alpha testers to my Whisper Demon Groups forum that didn't reach this larger group, the HamSCI antenna group, and even the larger HamSCI group. So this afternoon, I forwarded his offer for looking for test sites. The two first, I think the first test site in our group ought to be Michael's. But once we establish the setup and operation at Michael's, I think the next thing would be to put it up at your place, Nathaniel. So I think this offers, this antenna, I believe, will offer a number of advantages over the DX engineering. It is a fully balanced antenna. It's a vertical dipole. And as a result, it does not introduce ground loop problems to the ELF system that's co-located with it. There's no ground on this on Glenn's antenna. It's a dipole. But equally important, I think just about achieves the sensitivity and noise immunity that one could hope to achieve in a particular QTH, a particular site. So, but it isn't a one size fit all. I think that those of you who are interested in antennas, it would really be worth your while to read through Glenn's posts. I think this group, the larger HamSCI group may not have seen it. I can post. I'll forward Glenn's post into the HamSCI group. But he goes into a long discussion of the design goals and the specifics of his antenna, which I believe is truly unique among all of the receive antennas. Of course, is a receive antenna. I think it's pretty much a unique design, and it's based upon Glenn's understanding and modeling of transmission of radio waves in space. He has a model that called surface wave transmission line model for modeling the operation of antennas and communications of other radio frequencies along conductors. And his model of how it works results in a significantly different approach to receive antenna design. And and one that allows you to achieve in it appears like close to optimal receive conditions, given the characteristics of a receive site. So if this subject interests you, the receive antenna, you can easily improve your sensitivity, reduce your background noise level by 20 or 30 dB or more. I mean, it is startling. We've Elmer and N3 AGE has been deploying Glenn's antenna at his suburban home out on Long Island, and it's just amazing. I mean, all of the there are many RFI sources that are just disappear when you have a truly balanced antenna like Glenn's design. So I'm not aware of any commercial or even anything in the literature that describes a antenna like Glenn's design. I mean, there are active antennas, there's active dipoles, but there's the combinations of what he's done in his antenna design, I think are unique, and I think would really help a lot of receive sites outside of our project. But I believe it's really useful for us. So that's the antenna project. I think that hopefully we'll move forward on that one.
So you think your recommendation is can you go the differences between this Glenn's design and say like the DX Engineering Active Whip? What are the highlights again?
Okay, well, the DX Engineering Active Whip is an unbalanced antenna. It has it is a probe antenna. That means that it's depending upon the Earth, what the characteristics of the Earth as half of the antenna.
Right.
And now Jonathan pointed out that for an ELF antenna mounted nearby, that ground connection would without sufficient filtering and so on, that unbalanced DX Engineering antenna is likely to severely impair the operation of the ELF antenna. And in some ways, it's the problem is one of the further problems is the characteristics of that will vary from site to site. The performance of an antenna like an unbalanced antenna like the DXE is very much subject to the characteristics of the ground. And when the ground characteristics change, i.e., the snow falls, the snow melts, suddenly the ground behaves very differently so you have the DX Engineering is not a very good reference antenna. It's not and in fact, I think Glenn would argue that even the ITU measurements using their reference antenna are subject to the same problems. It's an unbalanced antenna. And so in contrast, his antenna being fully balanced. Okay, it's immune to the effects of the ground that it's put above. So now there are still other things, site to site, there are lots of variations, but that ground, that characteristics of the ground and the danger of the impairments they could introduce into the ELF system argue that having a fully balanced active antenna will result in much more reproducible results. And there are there's a couple of features he's added which will help us as the antennas are installed to help us calibrate and verify the performance of the antenna at a site. One of the features is that he has the ability to remotely short the antenna terminals. That actually is an incredibly valuable way to measure the performance of a receive system. If you short the antenna systems and you don't see all the signals go away, that means that your antenna isn't just those wires hanging up in the sky.
It's the feed line itself.
And the wiring in your house, who knows what it is, okay? So his antenna, you can remotely instruct a mechanical relay to short the antenna terminals.
Yeah.
And you can watch at his site, you can watch that everything drops 50 dB.
Yeah.
Okay.
Hmm.
I mean, you can't drop a 30 dB, at 30 megahertz, but that everything drops, goes away.
Yeah.
So
this sounds very, very interesting.
I think that not only is it highly performant, but it also has features that allow us to calibrate and verify the performance of a DAISY to receive site.
Yeah.
Do
And
you have a URL to share or anything that I could use to help find this?
yes, I will post a link to his posting. I'll put this in. Here's
And
see
the
if I can find, let me find his
the frequency sensitivity of this.
It's ITU quiet rural, below quiet rural, all the way up to 30 megahertz. So it's and this is here. I have this one in front of me. I'll put this link in your in the chat. Well, you can copy. Commands, Command A, Command C, Command V. There's a single antenna. He calls it the single antenna system.
Yeah.
And with sufficiently large, it is a fully balanced system. Basically, it can go down to DC. I mean, it's a function of here's the link to his invitation, Glenn's invitation in from my Whisper Demon forum. You can go there and see his invitation for alpha testers. I mean, among the things that Glenn has observed is that for active antenna systems, at some sites, your biggest problem are your local FM transmitters.
Mm-hmm.
So you really need to have a field probe and or a tiny SA Ultra. So you can go up there and see how strong are the FM signals. Because they could actually your local FM transmitters could be the source of your impairments into your shortwave reception. So I mean that's true. That's true of any active antenna system, which would be true of the DX engineering. But I'm not sure anybody's looking at what's going on, and it's hard we typically don't look above 30 megahertz. Unless there's pretty severe, evidence of pretty severe FM overloads. But these are all if you read Glenn's presentation, he is looking for people who want to actively involve. This is not something that you can just, if a high performance antenna requires an investment of time and understanding.
Mm-hmm.
It's not something you can just throw out the window and say it'll work for everybody. No antenna works that way. Okay.
Mm-hmm.
Any antenna that you put up is very much affected by your particular installations, the characteristics, your location, the transmitters nearby, the propagation characteristics, all affect the performance of the antenna system. Glenn's approach, I think, gives us the tools and the insights and the ability to measure and deploy an antenna that can, for those of you who are in a urban environment, you might be surprised how well you can do, how much more you can receive with this kind of antenna than you can with what you're using now. Anyway,
Rob, what does the antenna look like physically in its size?
Well, here, I'll show you. I can show you a picture of it. I'll share a picture of it.
I'm sharing the do you see what I'm showing?
No, it's just a
Seeing
screen.
a tower.
Oh, well.
I'll
I'll let Rob go ahead and show. I must have been sharing the wrong screen.
Okay, well,
I thought I was sharing his website, but
it
yes,
looks
well,
like a whip.
Yeah, well, what it is if you look, I'm sorry if this is, are you
Well, it
seeing
has an
this now?
element up and down.
Okay,
Yes.
so
The
this is
dipole.
this is a dipole. The electronics are at the center point of the dipole. If you look down at it farther, he'll tell you this is a 23-foot fiberglass whip that you could purchase from on Amazon for $39. And you can strap it to a fence post. You can, if there's an auger, you can put it into the ground for a temporary installation. And for a long-term installation, you probably want to guy it. You almost certainly want to guy it at least at the midpoint. But it's very, if you go down further, you can see the components here. There's the schematic of it. You can see, you can see, here's the materials list. It is still in alpha. I would discourage anyone from ordering these parts from JLPCB. There's still, there's still refinements. You need to talk to Glenn before you proceed with this. But he is actively soliciting people who are interested in this, who are willing to invest the time to understand what it takes. He's eager to work with you, and his goal is to produce an antenna that is widely usable and makes many hams, including those of us who are in rural, urban environments, able to actually receive signals and minimize the effects of all of the things around us. But this is a picture of the antenna. It's hard to see, I know, probably. I can't see what I'm showing you at the moment, but this is it attached to a fence post with the little box that has the amplifiers in it. What is surprising to me, most surprising about this design, is that based upon Glenn's unique analysis, the surface wave transmission line model, you can move the Cat5 is actually running down next to the lower half of the dipole. And standard models of how this works would suggest that this would produce a tremendous imbalance in the antenna. But his surface wave analysis predicts that it will not, as long as the Cat5, he uses Cat5 here, is kept, I think it's something like 50 wire diameters away from the antenna element, that there's no interaction between the two of them. So this antenna sitting here is balanced to about 50 dB of common mode rejection, in spite of the fact that the Cat5 is going down the lower half of the mast. That
Rob,
is so unintuitive to me. It's unbelievable. Yes, question.
Rob, in his solicitation, he says use his address on QRX.com.
That's fine.
Does he mean QRZ?
He probably means QRZ, yes.
Yeah,
QRX and I think
I'll get in touch with him. I definitely want to try this.
Yeah. Anyway, there's some details about of course you have the plastic box which he's designed and that contains the electronics, and then there are clips that are designed to hold the feed line and to keep the lower element and the upper elements attached to the mast but distant from it far enough that the feed line and the lower element don't interact. So this is
sorry, he feeds it with Cat5 instead of coax?
Yes, yes, absolutely. It's a balanced system. You want to use you use the twisted pair, which is Cat5 is an excellent it's excellent, well characterized for RF balanced RF transmission. So it works very well. And in fact, it turns out the unshielded, almost the cheapest Cat5 you can use works just fine. If it survives the weather, it's you do not want to have shielding. You don't you don't really, you know, you don't need to do, you don't, this isn't, this is a very, there are a number of elements to this that surprised me, and then one of them is, that the quality of the signals that you obtain. But at his site, lives in suburban Fort Collins, so he can compare the performance of this antenna against the remote antenna system that he has up on top of the Rocky Mountains, about 20 miles away.
Hmm.
And that site does better because it has the slope down to the horizon. So, at certain times of the day, you get much better, low angle propagation. But most of the time, this thing works just about as well as you could hope for a single antenna. Now,
Is there
this is, yeah.
so is there sort of any a reason why the electronics is set up halfway through the dipole? Does that have any sort of impact on the characteristics of the wave propagation, or is it just random?
It's a dipole, so you want to keep everything as balanced as possible. So that's why and you want to, and it's a broadband dipole, so it's not resonant. You don't want it to resonate.
It's a short dipole, center fed, and you want the preamp right at the center.
You want it right at the center so that you can, because you want it, the input impedance of the operational amplifiers in this is on the order of, I think it's 200 kilo ohms or something. So he has very high input impedance. So you can't transmit that the signals that are the electrical signals at the center point of the dipole cannot go very far on a transmission line without they being completely impaired. So you want to have the inputs to the amplifiers, high impedance amplifiers, right at the feed points of the dipoles.
What kills you is the capacitance of the feed line. So you need the preamp right at the dipole itself, right at the antenna elements.
Yeah. Yes, right at the antenna elements.
The capacitance of a feed line acts as a voltage divider.
Yes.
And directly affects your sensitivity.
So you can see down here, this is the chart that shows the three ITU curves that you'll see the noise level that you would expect over frequencies at different typical locations. The orange or yellow one, I guess it's roughly yellow, is of course urban. And then I think that the green one is again urban. As you go down, you can see you can get to a quiet whirl, okay, which is the blue line. And the red line is the noise figure of the amplifier system that he's created. So you can see that all the frequencies up to 30 megahertz. Now the noise level contributed, the noise level of the noise generated by those amplifiers, the active amplifiers, is lower than the noise that you would get from at a quiet rural location at 30 megahertz. So once you reach that point, given this level of performance, this noise level being that low, then you hear everything that can be heard. I mean, the only thing you can do after this is to put in a directional antenna. The directionality will give you better performance. But for an omnidirectional antenna, you can't do any better than this, than the ITU numbers. If your system doesn't contribute any more noise than the less noise than the ITU, what's coming from the atmosphere, then you're going to hear every signal that's there. I mean, that's given that your receiver and the rest of your receive chain are similarly optimized. But that's his goal, and I think he's achieved it. There are trade-offs because this antenna, to achieve that level of sensitivity, requires a 5 meter total dipole vertical dipole length. So that's at many sites it may not be even useful to have that tall a dipole, that you may be better off just shortening the dipole because you got so much local noise, and that you're not gaining anything, and you're just introducing overload effects. But there's a bunch of subtleties to this. You need to study every receive site. You need to take a look at it, which is why we need to start, but we need to do that anyway. If you're going to put out receive systems, you need to be able to take a look at their performance and understand how well they're performing. And we have the tools to do that. We have remote access. We can take a look at all of these, the antennas as they're deployed remotely with a modest amount of help from the local ham, whoever's the hosting person. We can establish how well it's running. And and we also, one of the things that we need to do is qualify sites, because it turns out FM transmitters are a big problem and for any active antenna system. And so we need to understand beforehand if there's a, if some otherwise quiet site is 2 miles from a 100 kilowatt FM transmitter, that might not be a good QTH for a DAISY 2 deployment. Anyway, I know I've gone on for a long. If there are other questions, you should contact Glenn.
Yeah, I think this is really, really interesting, Rob. I think there's some compelling reasons why we might want to use this antenna for the receive site. If for the official receive antenna. One of the I'm curious if we could get some input from maybe like from either you and from Gary McKeaton and from Dave Larson as to how we would handle this logistically for getting it out to like a larger deployment of 25 or 30 stations.
Yeah. That's what gives me pause is I really would prefer, I would prefer for us to buy something from DX Engineering. It would be a lot easier not to have to deal with this.
Yeah.
Well, we have what you might call our manufacturing branch.
Yeah. I mean, all the components can be ordered from JLPCB. I mean, so they're orderable and they come assembled.
I mean, I guess the first thing from talking to you before, I have never talked to Glenn Elmore directly, but from talking to you, you've relayed to me that Glenn is really is happy to have people use these things and is not really interested in manufacturing or productizing this himself. Is that correct?
Well, I think his outreach, I think, is encouraging to me that his attitude has somewhat changed. I mean, he has invested enough time in this project now over the last year or two. Actually, he's been working on different antenna systems for the last 2 or 3 years.
Well, Dave KV0S, you'd be able to answer this better than I, but isn't this something TAPR would be capable of handling?
Yes, it is something that TAPR. The real issue is we can't, unless he's explicitly written something in the copyright statement, we can't just go take it and
No, I
manufacture it.
understand that, but if Glenn allowed us to.
But yes,
Glenn would be eager to have you take it. He's been a little discouraged at the glacial pace of his GPSDO design at TAPR.
The real thing that we do not want to be shipping pieces of tubing and things like that. So how do you control or make it clear what people need to buy to make those parts?
The mast is you can order it off of Amazon and get it delivered. You don't have to. It doesn't have to go through TAPR.
Okay.
Yeah, well, this would be like our magnetometer project where we supply the board and they assemble it.
So if Glenn wrote an agreement with TAPR could then do the kitting of everything except for the long tubes and things like that, right?
Potential.
Potentially.
What we really need, as much as anything, is a volunteer that would take on the task of putting the pieces together
Mm-hmm.
and make them available. We have an online store, but the
Right.
physical presence of it is in Michigan.
Right.
So somehow they have to get from whoever. We don't have the physical. We might have somebody who wants to do it.
I
Maybe.
think what Dave's trying to say is any project that TAPR wants to take on these days, they want to be sure there's a either someone who takes responsibility for the
Yes.
for the product. And
Well,
Mhm.
and
you know,
particularly
kind of a
with
way where-
shipping to China, we found that there are real issues with one person doing it for a while and then shifting to a different person. That person doesn't want to do it anymore. And it turns out that it's very difficult to have multiple people accessing stuff. But maybe the way Glenn did it, it may not be a problem.
Mm-hmm.
So we'd have to explore all those
Well,
opportunities.
well, Glenn's trying to, if you read through it, he really is trying to make it available to the
Yes.
general public and to anyone who wants to manufacture and sell it. He has no desire to make any money from the design or anything. He just wants to see it deployed and used.
Well,
Now,
what we would charge is basically the shipping and cost of the parts.
yeah.
Well,
The other
So,
thing, there's a limited time frame too. We don't need to produce these for 5 years. We need to get
Yes.
30 or 35 units put together, and then are we done? I don't know.
Yes.
now,
yeah.
well, I mean, I think it sounds like, I guess the question is, how well are these things going to be adopted? It sounds like it's quite a different design from many of the other antennas that are out there, and it sounds like this sort of thing that might have more widespread interest beyond just this personal space weather station. And I mean, the way I'd like to see the personal space weather station grow is I'd like to see it not just stop with these 25 things. I am trying to kind of grow this. I'm hoping that as long as I can be a professor and as long as HamSCI can exist, that we're able to keep growing the personal space weather station network and improving it. So
Yes.
I don't necessarily, it's hard, from right just tonight, it's hard to tell exactly where this will go
Yeah.
5 years
Well,
from now.
yeah,
but
in part, we're definitely jumping ahead here
yeah,
because we need to evaluate it first.
yeah.
Right.
And we need
So,
to consider
yeah.
things like lightning susceptibility. I mean, there's a nearby lightning strike. Which unit survives better, the DX engineering unit or something like this? Because that could be a real weak point.
I'll just say right off, though, that there's nothing really unusual about Glenn's design, but it's been carefully laid out, and it's using a dipole instead of a monopole.
And I
It
will
has been done
mention,
before. I mean, HARP uses such antennas. There's a lot imaging rheometers use such antennas. It's
And-
not that unusual, but
I
it does look like it's been well done.
I also want to brag a little bit that Dave McGaw is now on our board of directors at TAPR, and as well as Paul Elliott.
That's great.
So we've added those additional people, and that makes more of us that are involved in HamSCI participants in TAPR.
That's really good.
I mean, a vertical dipole is not a new design, of course.
Right.
They've been around. I mean, I have a Gap Titan DX, which is a vertical dipole.
Yeah, it is. But what is unusual is for a receive, I believe, for a receive antenna to be able to actually have the levels of common mode rejection because of the ability to the balanced and the ability to have the feed line run next to the downlink element. I'm not sure, there are the gap DXs. I bought, that was the first antenna I bought, and I hate to say I was such a piece of, it's unbelievably bad. I was just appalled about that. We struggled with that antenna with a bunch of HP engineers and got it to resonate. And even then it was 10 dB down from a simple dipole on any antenna. It was just, so I think
Well,
that
this is an entirely different beast anyway.
this is
The
a
gap is a
receiver.
resonant antenna,
Yeah,
theoretically. But this is not resonant. It's been used for research, this form of design, in many places in the past. But
Yes.
the question is, Glenn's implementation, which sounds like it's a very good one. So we should very definitely evaluate it.
He makes it quite clear though that thinks he's very much in the alpha stage, and he's looking for people to help him verify the design.
Right.
So
Which
I think that
able to do.
Yeah, I think that the alpha quality, I think, of this is more that he believes that there may be the operating parameters of the antenna may need to be adjusted based upon the individual QTH more than one might hope. That the sensitivity that such antennas have to local FM transmitters and Glenn is 15 kilometers from WWVB. He's got 100 FM stations line of sight across the Front Range, so he sees tremendous. You have a U-shaped spectrum. He's got 60 kilohertz at 0 dBm, and he's got a whole set of minus 10 dBms up at 100, 90 to 100. So his situation, his alpha testing is not so much oriented toward that the quality of the design is that how do you make this, to what extent does this design need to be customized, or can there be a kind of reference configuration, gain settings, size of the dipole, can there be a single setting that is widely enough usable that it doesn't have to be tweaked for an individual site? I think that's much more of it. It isn't that he's been through about 4 or 5 generations on his own in terms of finding the amplifiers and the line drivers and so on. He's pretty well done with that part of it.
This reminds me of why it's said that if you wanted a good FM tuner, get one that was designed in Boston.
Yeah.
The RF environment apparently is extremely strong. So, that's why Fisher and H.H. Scott and AR and all those guys, they were all in the Boston area designing very good FM tuners.
in the automotive industry, we just drive through Southfield. That's known as Intermod Alley.
Well, I built that first kit that I think I built was an H.H. Scott FM tuner. It was a very good tuner back in the 60s.
They built good stuff.
Yeah. Anyway, this is a study. I'm not saying this is the solution, but I think that there's a lot of reasons to invest time in studying and trying out this antenna for our application.
So
yeah, go ahead, Dave.
for your DAISY grant,
Mm-hmm.
It seems like this is a good piece of equipment. The question is it ready for putting your whole grant process or the whole project, the beginning of your project, on only these antennas?
That's a very good question.
Well, the short answer is we don't know yet.
We don't know.
Mm-hmm.
And that's the question.
So we should get about testing this.
And I think testing is the way to go about it, but there should be a fallback if in some case you find that this doesn't work out.
Well, we have that's the whole point of we have the DX engineering, and Michael has one installed. So we're in, and we could do the same thing. I think that as a second site, Nathaniel seems like a good candidate because especially because he has a magnetometer and Jonathan is, there to work with you
And
and
I
verify.
already have Cat 5 run out to that site.
Yes.
I've got both Cat 5 and RG6 run out to that backyard, and I have dark, available lines of both. So it's relatively out of all the different things I could deploy, that's relatively little stress to
Okay. Well,
Yep.
I don't know
that
if
out.
you're up for being the site technician or Majid
I
could
think
do this.
I think the way it would work is I think Jonathan and I would probably be the two people to be working on it together.
Okay. Okay.
But
Well, I think
I
we can
I
do this.
yeah.
I think it would be interesting to find out because in some typical installations, it's going to be side by side or well, not exactly side by side, but in near proximity to a transmitting antenna, a ham radio transmitting antenna. And the
Yeah.
question is, can it survive that, or is it going to blow the whole front end out?
Yeah.
Yeah.
Well, Glenn has his installed about, I don't know, 10 feet from his whisper transmitter. Okay.
Yeah.
And they work together okay. But you're right. I mean, if somebody's doing high power transmission, it won't be damaged. I mean, he has protection in this, but you're not gonna. We have this problem at Dave Schwartz's WWV site. The receive site is so close to the WWV transmitters that that I don't even think it's a dynamic range problem in the receivers. I think that the WWV transmitters just smear out, even though they're pretty darn clean, they smear out into the whisper bands and they raise the noise level and the background noise level at that site. So but I think that's part of the criteria for selecting these sites. Gary, is I think you're the person in charge of site selection. And I think that one of the criteria has to be to understand the characteristics of the site. You really, I think for Daisy, I mean, you're in charge, Nathaniel, but I would think that we would prefer not to have a site where there's a nearby, i.e. within 100 yards or so, strong ham radio transmitter. I mean, that might have that when it's in operation, it will inevitably impair the sensitivity of any receive system. Not
right.
So
Yeah.
I'm wondering, it seems like the other aspect is, as I mentioned earlier, other things like FM transmitters or local AM broadcasters and so on. Those too might be a reason to disqualify a site. And the host may not be aware of those problems.
I think I want to, I think I don't think I want to totally disqualify. I want because I want ham radio operators to be able to
Yes,
participate in this.
of course.
So an important design goal of this project is that ham radio operators can actually use these things. And I was talking to Gary last week. We were both in Northern Virginia together, and one of the projects that we have is to actually take the data from the personal space weather station and to create a display that would help a radio operator operating a contest or doing DXing or something be able to take observations from the personal space weather station, be like, okay, turn your antenna this way. Or so I don't want to. So there are actually, as good as for scientific reasons, yes, it's good to have it isolated from these things, but for certain other operational reasons and other goals of the project, I think it's equally important to have some of these systems be deployed at active amateur radio stations, because we do want to know how these systems coexist with active amateur radio operators, and we want to be able to know how we can how we can both achieve science and help ham radio at the same time. So
E.g. K3LR.
yes, so actually Tim Duffy has offered to fund himself the deployment of one of these personal space weather stations at his QTH. So one of the things we want to do over the summer is we want to have a joint Scranton, Case Western, and maybe NJIT trip out to K3LR to install whatever system it is we have. We want to start working actively with Tim, to how does this thing play out at a major contesting facility? So
Yeah.
I think there's both.
Is
And
there any
that's
opportunity to install one of these DX engineering antennas at your place, Nathaniel? Because that's the only VLF test site we have. And we could, while Michael and others are working on the Glen Elmore design, we could be looking at the DX engineering versus VLF.
yes, there is an opportunity to do that as well. So this may have to wait till after
Yeah.
AGU. But maybe over winter break if the weather's not too freezing cold. The nice thing is I've got I have the lines run out. I have both RG6 and I have an extra Cat 5 both run out there. So
Should be easy to do
yeah.
both. Yeah.
So I mean it is relatively easy, and I do have the funding to be able to
yeah.
do it.
Well, those are the two reasonable, I think. I mean, I obviously I'm enthusiastic about Glenn's design, but I'm not enthusiastic about all of the becoming a manufacturer part of it. Even though I've seen such a dramatic difference in performance, sensitivity.
Yeah.
That I think
The other thing is, we have a 4-year grant. We don't, I know the timeline says we're going to deploy everything year 1. We don't have to deploy everything year 1. We can say we're going to try a few of these, get these out, get those going, get them stable, then we can deploy another 5. We can stagger it a little bit.
You have a track record of how you've done stuff like this in the past.
Mm-hmm.
So you can point to that.
Yeah.
I don't think the way we're gonna. You've done it
nobody's
before.
gonna give me a problem. I mean, it's and it makes sense for what we're doing too.
Yep.
Yeah.
So
I apologize. I have some family duties that I need to take care of. So
Okay.
Well,
I'm
happy
gonna
Thanksgiving,
step out.
Dave.
Okay.
Yes.
Okay, Dave. Thanks. I have a couple of other topics that the antenna led us into a long discussion, but I do have a couple of other topics. I encourage Larry to join us because he mentioned in his section about posting up these Russian beacon Doppler spectrograms. And I think Larry's point is that this is a unique source of Doppler shift and propagation information, the signals from them. And I think I can just add a channel to the Whisper Demon Grape and just specify his transmit channel and have them posted up. I don't know that affects, that they just be an additional receive channel as part of the DRF upload.
Yeah.
I mean, it will increase the data size. And do you feel like this is useful and compatible with the goals of the weather station project? That's the
Okay, so I think I missed part of Larry's discussion earlier. So we're listening to which Russian transmitters?
There's a whole bunch. They're basically the Russian remote nuclear launch communications network. This old CW network. They transmit on a whole bunch of different bands. I'm a 40-meter interest guy. there's one on 7039.3 kilohertz. And the important thing to me, and I've looked at this for years, it's the only beacon on the North Pacific Asian coast that's on all the time, 24/7. None of the JA beacons, none of the JA or Korean time signal stations, they're all low power, so they don't actually cross the Pacific usually. This one's on all the time. So it's a good reference. It's frankly, I got together with Rob because frankly, he receives much better up in the Bay Area than I do down here 500 miles away in San Diego.
Mhm.
So, but it's the only beacon over there, the only usable 24/7 40-meter beacon. That's
Is this a continuous carrier beacon or is it CW? What is it?
it's CW. It's a series of very slow K, da da da, only real slow with the spacing in between.
How much bandwidth would we be saving?
It'd be the same as a WWV channel. It's just add one more channel, 10 hertz wide, 24
Would
hours
we
7.
would we be having all receivers receive this, or just select receivers?
I don't, it would make sense to me that only do this from sites that are actually likely to receive it, and which for right now means there are 3 sites here on the West Coast. There's a KFS, KPH, and for RPE up in Seattle. Those are 3 high sensitivity Whisper Daemon GPS disciplined receive sites. So
It seems reasonable to add this in for these sites for now. I think one thing we want to do is I I don't really know all of the technical details of how the Alabama server system works. So I don't know what happens if you simply add a receive channel to it. I don't know if the system will automatically adapt it or if something needs to be coded in by Bill
yeah.
and his team. So I would suggest that you do that. And the other thing that I think we have to do, I think you know, and maybe we may have to come up with a more formalized process of doing this, but if we add additional channels or experiments, I think we're going to have to come up with some way of documenting why we're adding these channels or what they mean, because it started off, all things start simply. So it started off very easy. Oh, we're just listening to WWV on these channels, and we all know that the grapes listen for WWV and WWVH. Okay, well now we're adding CHU, and now we're adding these other things, and before you know it, we're going to be receiving all these frequencies, and you're not going to know what you're looking for. So why are we receiving this frequency? So I think we're going to have some way of keeping track of this. Now, for this, one way to do it is for this particular channel, you could write up a document that explains why you're listening to this and what you should be listening for and things like that. And if you upload it to Zenodo, then allegedly things that get uploaded to Zenodo stay there for all eternity until after the sun explodes, and they're always going to have the same working URL. That's what they promise us anyway. But obviously it's not going to be quite that good, but the point is it's supposed to be a rather permanent address. And what you can do is once you have that DOI address, if we have for every channel you're able to include some sort of metadata. So, you don't want to include a whole like experiment description in the metadata for every timestamp, but you could include like a DOI or a URL that points you to a longer project description. So when we add this channel, you also add to it the in the metadata, the DOI that points to the Zenodo repository that has a description of why we're listening to what we're listening to. And then that would, give people some sort of reference as to why do you care about this particular frequency.
I've already prepared something, and I'll send you a copy, Nathaniel, and also Bill. Is Bill the fellow that?
Bill Enkoki,
I
yeah.
don't see him
Yeah.
on tonight, but
He isn't usually
I'll
here.
I'll send it to Bill too. Rob and Gwen already have a
Yeah.
copy of it.
yeah. Yeah, but I think if Rob thinks it's useful, and he can encode it into Whisper Daemon recording, and then if Bill says okay, we can add a channel for these couple receivers. It seems to make sense to me. I think then the missing piece is let's get that description up onto Zenodo and have some way of, encoding that what we call the DOI URL into the metadata itself, so that when someone downloads the data file and they say, what am I looking at? They can just, it points them to that URL, and now they have some sort of a description of why am I looking at this particular thing?
Okay, that's good. So, yeah, you have the action item is in your right now for you, Larry, to forward that to Nathaniel, Bill, and CC me, and we'll go forward.
And Larry, it's nice to see you on here. Thank you.
Thank you.
Yeah.
Good to see you.
Okay. Okay. So one other topic, but we can keep this one short, is that I am been trying to reduce the cost of the receive system, the Whisper Daemon Grape system by using the Orange Pi as the host rather than a B-Link. And the Orange Pi, I think I've described it before, but it's like a Pi 5, except it has twice as much CPU horsepower. And you buy it for $100 on Amazon. It's been in production for quite some time. You can plug a AAA into it. Together they consume on average about 10 watts instead of 23 watts for the B-Link and it costs together about $275 instead of $450. So the Orange Pi is tantalizing. I can find no other widely available single board computer that utilizes the rock chip. I forget the part number, but it's a 8-core rock chip. So it is a kind of unique solution in this. It's one vendor for it, but it's been around for quite some time. So it's been available for years. The only problem with is that it has this one problem that it drops packets in about 0.01% of the packets get dropped. And I have been digging in. I mean, it'll run. The packets get dropped only when the packets are being sent to itself. It doesn't. If you can send out packets to other computers with no trouble, it can receive packets from other computers with it can be receiving itself and the other computer at the same time. And the only packets it drops are the ones that are turned around on itself. I've been poking around at kernel buffer sizes, and it happens. I mean, it's anywhere from once every 5 minutes to once every 15 minutes. But it's as soon as that happens, the whole recording thing falls apart for minutes, because to resync. So it's not useful unless I can get it working. I don't know that anyone in this group has more insight. Tom sent me a note. I had experimented with the kernel buffers you described and a few others, Tom, and they did make some difference. It somewhat improved it when I increased those buffers. I went from the default of 5 megabytes of packet buffer in the kernel to 125 megabytes, and it went down some. But there's some unique choke point inside the path for multicast packets. I can be sending unicast to myself, 100 megabit unicast at the same time, not a packet dropped. Okay. But it's the multicast packets that are sent back, turned around and sent to itself that get lost.
Yeah.
Occasionally.
So those packets all have to be processed twice.
Yes, I know. And so there's some point in there where there's some program that under CPU stress, this, of course, the occurrence goes up. If I run stress and I get all the cores running at 100%, actually, it doesn't change that much. It'll run. It never, even at 100% stress, it never drops a packet delivered through the Ethernet packet, a multicast packet. It's only the turnaround packet. So there's some path through the kernel's IP stack that that is a choke point, and I haven't been able to find it. And
About a year ago, I ran into that problem where Ethernet switches would drop multicast packets at a 0.1% rate and never drop a unicast packet at all.
Yeah, well, that's the unicasts are handled by hardware, and but of course but a turnaround unicast I don't think is so different from a turnaround multicast. So it's a mystery to me. There must be some unique service inside the kernel that's handling multicast that turnaround multicast.
There is a lot of DMA buffering going on, and so and how much of that applies to hardware and how much of it applies to loopback, I don't know. But you've got 3 memory copies you got to make on loopback, so
well,
who knows?
the i5 6500T, which has roughly the same CPU horsepower capacity as this, never doesn't exhibit this problem at all. So this problem is it's unique to the hardware, to this 8-core ARM. Running same, I'm running Ubuntu Linux 2404 on these machines. And so it's the same operating system, obviously a different CPU. Okay, it's an Intel x86 versus an ARM, but it is, I'm keep kicking myself for investing time in it, but it's such a, it's so close to being a really, really good solution for many sites. Of course, the DAISY sites, and the lower power is almost, I think is almost as important as the lower cost. So it's just, you end up with almost no fans needed. I mean, you have the whole thing gets to be a real appliance kind of receive device.
The various processor architectures have different memory drivers required. They do DMA differently. They have base address registers that are different, and you got to write a different driver for every CPU architecture. And there could be something in the ARM and the ROC implementation that still has a latent bug in it.
Well, it seems like a bug. I was trying to go to a newer, the stable release from Armbian seems to be the people who do the best job for ARM processor in Linux on ARM. And I've been using their Ubuntu 24, which uses the 6.1 kernel. And I tried they had a Debian 12 that had the server distro with Linux 6.10 kernel, but it wouldn't talk to the USB device. It wouldn't see once Franco's code loaded Franco's high-speed code for the thing, the Linux didn't recognize the USB device once it upgraded that software. So I posted a question up, but I don't expect much help from anybody on this. I don't know if Franco. This is not a problem for Franco really. It's the Linux kernel developers, and I don't think we've got their attention. I don't think they're going to pay a lot of attention to our FX3 and our X888 systems. Anyway, I think that covers
there's DMA designs, and then there's DMA designs. And
Yeah.
I have dealt with some pretty buggy ones in the past. So
Well, it appears that this very well could be there's some kind of a memory copy going on that is and I
yeah.
couldn't that is failing, and I was looking for counters to see if there's any of the netstat kind of counters would indicate drop packets or something, and I can't find anything that would indicate to try to localize where it is in the path. So I was you know, I and I was trying to think maybe the fact that there's is attached to an Ethernet switch. Perhaps the multicast stream is getting routed out to the switch and being sent back, and the loop back happens out in the switch, not inside the kernel. But this particular version of the Pi 5, Orange Pi 5, has no Wi-Fi section, so I have the only way I can talk to it, and it doesn't have a console interface, so you have to have the wired Ethernet connection in order to to get to the console and SSH to it. So I'm banging my head against the wall here. But the Pi 5 is turned out to be not useful at all. It just doesn't have enough horsepower for this at all. It surprises me because it basically seems to be it runs out of CPU power. It's just running radio D, whereas the Orange Pi runs runs at about 28% of the CPU for demodulation. So there's plenty of extra CPU cycles. So, an option is to just, okay, tell it to send the packets out to another device and set a second one next to it. And you've got two Orange Pis and one talking to the other, and one doing the radio D and the other doing the decoding. Seems a shame, to do it that way. But anyway, that would.
I just I don't know very much about the rock chip, but some DMA designs do cycle stealing from the main CPU when they're
Yeah.
microcoded, and
Yeah.
those things, as far as I'm concerned, are like less than useless.
Yeah. Yes. Well, something that is intermittent is
Yeah.
uh
I think that you'd end up having to go into the rock chip hardware specifications and see what exactly how they've implemented the DMA. You'll probably find out that it's not as good as you think.
yeah. Well, we could turn on, it would be nice if we could just turn off the DMA for this particular
Yeah.
path, and just do a mem copy. It's a copy. It's not that much data. It's only total of 10 megabits of data. So it's not a whole lot. It's a shame. Anyway, sounds like you have more experience with this, Dave, than I do. So it's
Back in the day when I was doing machine vision stuff,
uh-huh.
we dealt with the fact that the DMA implementation in the chipset that we were using was like worse than useless. Because it was poking holes in our CPU, right?
Yeah, interfering with the mainline. I don't get any other errors. So in the system, so it's not like it's corrupting main memory or it's corrupting the buffer space. It doesn't, these failures do not propagate to any other part of the system. No other part of the system is affected when these things. Isn't that strange? If we're corrupting, if we're cycle stealing or doing some corruption of memory transfers and disturbing other DMA operations in the system, I could then that would make sense. But this is only a simple packet loss in one multicast turnaround stream. So, anyway. I thank you. I've taken enough time on that subject. I've burned up time. If anybody, I don't know anybody. That this is a Huawei product, I think. So I'm not going to get any support out of the manufacturers. I don't think they would help me. It's hard to reproduce. I mean, I can't it's hard I haven't figured out how to stimulate, just create a multicast stream with a multicast listener. I was trying to do it with iPerf3, but iPerf3 doesn't really deal with multicast sending and receiving. It does unicast just great, and of course TCP. Okay, any that's why I'm at the end of things. I think of the list here because I end up consuming an hour or more.
Well, I think that was really good, Rob. Thank you for all of those updates. And I'm really appreciative to you and Michael and the rest of the antenna group for doing all of that quite extensive work on the antenna project and all the projects. Um, I'm I'm looking forward to continuing to see the progress of the antenna group. Um, I will work on getting some of those antennas installed at my house as well. I guess I'll be in touch with you and Michael.
It would be good. I sent an email out which I directed to you and Michael. If you could respond directly to Glenn, each of you,
Okay.
and tell him that you're interested and that you'll want to work with him on this. I think that's what he would like. He would like to hear directly
Okay.
from you. Okay, so
Great.
he is assembling a list of alpha / beta test sites. Now Glenn will supply the hardware either himself or Elmer, who I mentioned earlier, has obtained 5. He placed an order for himself and had to with JLPCB. He ordered 5 assembled receivers. So the board that goes on the antenna is the same, but Glenn has evolved the design for the shack board, right? The bias T, if you will, that's end of it, and eliminated the transformer down there. So that reduced the cost and increased the common mode rejection significantly, and moved the low frequency point for the antenna system to well under 1 kilohertz. I mean, he mentions 10 kilohertz to 30 kilohertz, but that's because Glenn isn't looking at lower frequencies really. And I think he didn't put the coupling caps he has on in the transmission chain. He just needs to put in larger ones to accommodate lower frequencies. But so potentially it would be interesting to see compare once you get one installed. And I expect that probably you could anticipate this sometime maybe by the first of the year, for you, Nathaniel. And I think we go to Michael first with one to Michael, and then once Michael has some experience with it, then you could do it. But I think that your site is the most useful because it's the closest. You have all of the componentry of
Yes.
a Daisy 2 site at yours.
So I think that's a good plan because if you and if Michael can kind of work out the okay, here's how you set it up sort of thing, and then you ship us the parts, then I can and then when we have questions, Michael can say, oh, do this, do that, and then I'll be like, okay, yes, we'll do that. And and I can get
I think Michael and I are looking to, through this process, become the installation support team for deployments, and because we'll do that. I do, just as an aside, I just shipped out 3 of the field probes, the second batch of field probes. I haven't heard from Majid about your receive site there at EDU. I think we've kind of lost contact there. But he has a field probe, and we were going to do some work to refine to see if we couldn't improve the sensitivity there at your at EDU and at the university. So I don't know whether I should be reaching out to Majid. Is it Majid? Majid?
Yeah, Majid.
Yeah.
And so you want to do what at the university?
Well, he has a field probe.
Yep.
And he has severe interference. And so he was going to use I was suggesting he use the field probe to go up on the roof and look to see if he can't find a better location and orientation for the antenna you have there.
Okay.
And to do other things to improve to reduce the rather very severe RFI that system is
Yeah,
suffering.
I would go ahead and contact Majid,
Yeah.
and see how much he can help you with that. I think
Yeah.
that's a good idea. So,
Okay.
yeah.
Okay, well, I will reach out to him. I'm still working. I have to get the 32-bit stuff in, but I do have two field probes. I sent one to you, Clint, today. I sent one to Gary today, and then I went one to my HamSCI guys. So I have two of them here. If somebody else wants to use them, but you need to have a tiny SA Ultra, and you really need to understand how to use it, what you can gain from it. It's not.
Yeah.
It's a piece of test equipment, and
Yeah.
the field probe is a piece of test equipment that you use to try to understand and optimize your use of your particular QTH. So this is something that might actually have to.
Yeah.
I don't. Anyway.
Yeah, definitely reach out to Majid. And we have a new volunteer here who's been working with us since over the summer. He's
Yeah.
been more on the ham radio side and less on the HamSCI side.
Yeah.
But I think he's been very active with our club, and he's retired from the federal government, and he has significant experience doing technical things for federal government and sorts of stuff, if you know what I mean.
Okay. Yeah.
So I think he would be a very good person to team up with Majid to help. I think this guy would love to do things like hunt down RFI on the tops of university buildings. It seems like it's right up his alley. So
Okay. Well, you've got the tools. We just got to
okay.
have arrange
Yeah.
the time.
Yeah, so I think
Okay.
this guy will work well with Majid and will really help with that.
Okay. Well, okay, we didn't hear it all. Did we hear from you, Clint? You've been there. I don't recall that you got a chance to talk.
Don't have much to say.
Okay. I think I got you back contributing to the HamSCI personal weather station. Your system was off, not contributing for a while. So right now, I think all of the 20 sites plus sites that are Whisper Demon Grape sites, I think I get emails if they don't receive something. So I think they've all been working. So and that's it. Are we over? We rock chip. Microcode programming based DMA. Ooh.
Yeah.
I've got a question for Rob on a little bit different subject.
Yes.
You on Thursday you mentioned you wanted my help, and then Jim Farmer offered to help as well to write up a document to help get some of these I guess the whisper signs deployed. Was that what we were talking about Thursday?
We're talking about both the Whisper Demon. Basically, if you wanted to come up with a document, I mean, in my case, I'm thinking about the Australian Antarctic Authority. Presenting something to them about why they should deploy whisper sons and whisper, the 888 receive sites down there in Antarctica. I would Jerry, whose call sign escapes me, VK something, is in contact with the British Antarctic Authority, who he sees are very, want to have very formal kind of presentations. but just I think that it's the same thing is true for almost anybody who isn't part of our kind of circle of people, is even the people you would be presenting this to. If you're going to talk to people for the DAISY candidate sites, I mean, isn't there kind of a 1 or 2 page kind of document that says here's who we are, here's what the project goals are, and this is what the equipment that we'd install and what we'd ask of you in terms of internet connectivity and power and and so on. And it seems like that would be need for everybody, but in particular, the most immediate one is the these Jerry brought this up as with the Australians and British Antarctic
Okay.
management. But I
Okay,
wouldn't tailor it for them. I think it's a general requirement, for.
No, thanks for refreshing my memory. That makes a lot of sense. And you're right. We will need something like that. I really haven't got into that project at all, but that's what I'm doing, starting
Okay.
very soon. So that helps. Thank you.
Okay, well, that's if let's see what else. No, I think Clint posted up a question, Larry. Is Larry still here? Yes, you are.
Yeah.
About the stability of the those Russian K transmitters.
I don't know. I've tried and I can't find any technical information even about what antennas they're using. But I can tell you from listening on your SDRs up there, there it's a lot stronger signal than I get down here. It may be, I think these things are aimed at where their boomers are in the Pacific, and maybe off the California coast, further in the middle of the California coast, and perhaps further north. I don't know. I was going to check if you had any stations up in.
We do. We have the
You have an Ellesmere?
We have one in San Juan Islands up in near Seattle.
Okay, well that would be good. But it's very hard, and I've asked. There are a couple of former military guys who are interested in it, but they don't have any information either, other than the frequencies everybody knows.
Oh yeah. Well, you could find out. Do you know exactly where they're located?
Yep, the one I'm talking about is in Petropavlovsky, Kamchatka.
Okay.
I don't know where in that city, but it's probably not that big a city.
Yeah. Hey, maybe go down Google Earth and you can zoom in and find the towers. Okay. Well, I can't help you. I think that having
what specific stuff was Clint interested in?
Well, we, with WWV, of course, we've got microhertz frequency accuracy. So
yes, right.
Yeah, and we are able to measure Doppler shift on the order of 20 meters, on the order of 14 millihertz, is daytime Doppler shift.
Mm-hmm.
But you're looking at the signal you're seeing is going to be those are single skip transmissions, right? So we're measurements of WWV are single.
Oh yeah, you're right.
Okay. In your case, you're looking at multiple
3-hop 2C surface reflection.
Well, let's see. Yeah, let's see. We do have a receiver up in Inuvik, up on the Arctic Sea, and then we've got the one that's farther away. I don't know that the Inuvik one might be an interesting site to pick up, because you know where that is. It's right on. It's in the northern Utah. It's in Canada. It's a community that's on the Arctic Sea. In northern Yukon Territory, and one of my Whisper Demon users has I think it's GPS discipline system running up there. I don't look at it much, but Brian Kofflaw is a guy who does it. He would be a good source to
I was initially thinking that this might be a a directional antenna to cover the Pacific and the
Yeah.
Arctic, because their boomers go in the Arctic too.
Yeah. Yeah.
But also it's an Air Force missile guy told me that these signals are also for their mobile launchers, that are on trucks that
Yeah.
they run all over the woods and stuff like that, which
Uh,
would be inland too. So it may be a vertical or a shaped pattern of some sort.
Well, we don't have a whisper demon site. We've talked with some people about in Alaska about putting a whisper demon 888 site up in Alaska. If you could, I think you would find it would be good to be able to, if you could find a receive site that it was one skip hop away from them, and then you could begin to isolate the the effects of the water reflection, differentiate from the reflections on the atmospheric effects.
There is a one hop path occasionally that hits right around the Aleutians, about the halfway out on the Aleutians. So maybe one there in what's the Dutch Harbor or someplace.
Need to find somebody who would host it. That's the key, is to find somebody. Now that if we look at PSK Reporter and look for people who are operating FT8, they seem to be that they might be good candidates to approach to to see if there's if they'd be interested in going beyond their capabilities. If you do, I'm just looking here to see all modes, on all bands really. And I don't want to do 24 hours, but last hour, let's see. See if there's, find it somebody up here. I don't see a single FT8 signal out of the Aleutians right now. That's, but
I already checked. I think Hokkaido is one hop, the northern Japanese island. But I've already got through my Nagoya guys. I've already checked with hams up there, and they're not willing to do it.
We haven't had any contact with them about the Super Darn recording. So we're making them. I mean, I'm recording all this stuff. Is no interest, or is it just that we haven't reached out enough?
Rob, I've heard one station in the Aleutians, N8LF or NLAF. Let me check.
Yeah.
NL8F. I heard them on 12 meters at let's see, 0300 GMT today. Yeah. 3:17:45 GMT. I heard him on and it looks like he's all the way out at the end.
Well,
ADAC.
Well, grid square AO63RU, wherever that is.
I think Nathaniel's been to ADAC, right?
I have been to ADAC, and unfortunately, that radar blew over.
Yeah, I know.
It doesn't exist anymore. I think, what we're going to find, I think, as time goes on with this personal space weather station project, is that there's going to be more and more different sorts of observational modes we can add to the system. So, Super Darn, of course, is one. There's another system called CODAR, which my colleague and friend Steve Kepler has, and Ethan Miller, they've done work listening to CODAR radars that could be incorporated. There's the chirp sounders that Juha Virinen does, and he's like increasing his chirp sounder group. I think, with time, all of these different things could potentially be added to the system. But I think that it's just a matter of it's just going to take time. And I think the thing.
I did respond. You forwarded an email from a researcher at codar.com.
Yes.
And I immediately responded to him and said, we can
do
record
that.
your signals. Yeah, we will, but I never heard from him.
Yeah, I had a Zoom call with him and I never heard back from him either. So
Okay, well,
we may not be what he's looking for right now.
I
So
guess not.
so
We could easily give him recordings, maybe,
yeah.
but I think what we want to get from a CODAR system is very different from what they want to get. I mean, they want to, right? They're not looking for ionospheric.
Right, but Steve Kepler is.
Yeah.
And Steve Kepler and Ethan Miller, they have used CODAR for ionospheric sounding. So there are published papers out there that show how you use CODAR for ionospheric
Really,
sounding. Oh
really.
yeah,
Oh,
yeah.
really? Oh, well,
Yeah,
because
I mean I can give you
because we've been talking about how to do time of flight measurements,
oh
and
well
one of the things that Phil suggested was that maybe the CODAR signal, if it's appropriately modulated, might and timed, it seems like it would need to
yeah.
be. It
Here
seems like the CODAR system would be really found resource for a time
here
of flight measurements.
here's the paper. I'm putting the paper in the chat. Here's what you want to read.
We have a CODAR right here at Scripps Oceanography.
Right, yeah. So take a look at that paper, Rob. And I know, Ethan Miller is one of our HamSCI board member type people, and Steve Kepler is one of my friends and colleagues. So, we know the people that wrote this paper.
Ah, well, that's
So it's
okay. Well, that's oh, okay. Yes. Okay. This looks okay. Well, this is
so so if you're looking for something else to implement, that's shovel ready, as they say.
well, it's easy for me to record these signals. I
Yeah,
mean, Phil's, we've
yeah,
got plenty of disk space and recording bandwidth. It's just it took me a day to add Super Darn and
yeah,
Larry's recordings to additional in parallel with everything else that Whisper Demon does.
yeah.
So adding these recordings is the easy part, but what we need is someone who wants to invest the time
Well,
in studying the recordings, because I'll
yes.
overwhelm them with data.
Well, so that's where you have to turn these things into I mean on the scientist side, that's where you turn things into grant proposals, and then that's how you get people to pay attention to them. And so maybe there's someone out there who wants to do that and write a good proposal. But
Well, it seems like Steve and Ethan are more likely, and
well, and Ethan goes to Hamvention usually. So if you go to Hamvention again this year, you can talk to Ethan. Says he's local and he's K8GU. So Ethan is a
oh well,
yeah.
NAGU, not UG. That's a
Yeah, K8
Yeah,
K8GU.
yeah, and Steve's well known to us. I've
Yeah,
worked with him for years since he
AD0AE,
was a
yeah.
grad student.
So I mean maybe Steve wants to write. Actually, Steve might be the one to write the proposal for this, and I can chat with him about it too, because I could be like, hey, we'll have all these receivers. Do you want to write a proposal to collect this data and make use of the receivers? So he might be the one to write that proposal.
Okay.
Or maybe Gareth does.
Yeah, Steve's been known to come on our science meetings. We might.
Yeah, Steve does come on our science meetings, so he's been very interested. So, I mean,
we might want to have him come on and talk about it.
It's very likely that when I go to AG in 2 weeks, I'll run into Steve and he'll ask me how things are going, and we'll.
Why don't you to tell him? I mean, we have we can receive these things. Every Whisper Demon site, and there's they're around the world.
Yeah,
could be
I mean,
making these recordings. So it's not. It's
heck, I can just Kepler. I'll just send him an email right now. I'll CC you on
okay.
it. CODAR and PSWS.
Yeah.
Hi, Steve. Hope you are doing well. You came up in our discussion on the PSWS call tonight. We are interested. We like your paper, your AMT paper on the CODAR measurements. Now that we are deploying PSWSs using the RX 888, we might be able to use them for wide scale CODAR observations. Is this something you would be interested in? I'm CCing Rob Robinette, AI6VN, the Whisper Daemon developer, who could help make this happen. 73DE Nathaniel. Oh, there you go. So we'll see what
Okay, see if he,
yeah,
if he's,
'cause I mean he'd be in the ideal position to write a proposal and actually be able to do something with that data.
okay,
Yeah, so
great. That'll be, thank you.
sure.
That's, I think, what else? Like I already saved away. Look, I'm scrolling through that paper already. It's and learned that it's a 1 hertz chirp, monostat, sweeped signal. So, yeah, waveform, yeah, 1 hertz repetition rate, and it's yeah, about 25 kilohertz bandwidth.
What's the
Well, this is when was this published? Not a couple of years ago, so
It's fairly recent.
fairly recent. Okay.
what was
Yeah,
the
this is
frequency,
an
Bob?
active line of research of Steve's. But he's got his fingers in so many different things.
Wow.
He also flies sounding rockets.
Well, that's a
Well, I might say 73 for now. It's past my bedtime.
Yes, well, thank you. You've been here later than usual, so
I
maybe,
know so it's really funny. Some weeks I have this extra energy. I'm like, okay, I can go till like 11 o'clock at night. In other weeks, it's like 9 p.m. and I'm already falling asleep at the keyboard. So I can't. It's very hard to know from week to week.
By the way, while we're talking about Steve, he also would be willing to cite a receiver. He has talked to us, about doing that.
Yeah. So yeah, I think this would be awesome.
So I put links to the technical reference manual for the rock chipset. It's thousands of pages. But I will tell you that the
73, everyone.
DMA section starts